Hi everybody, it's Miss Lorenz. I'm going to talk about grade 6 3.1, topic 3.1, and this is all about exponents, which I know exponents aren't a brand new idea to you guys, but we're going to talk about it more formally now. All right, so the first thing I want you to know is how we read an exponent properly. So this exponent, 2 to the third power, or 2 to the third, is sometimes also explained as 2 cubed because of the third number, or the 3 number here. It means 2 times 2 times 2, which would be the cube of a number. So the place where kids go wrong when it comes to exponents is they forget that this right here is a multiplication sign. So this is not 2 plus 2 plus 2. That would be 2 times 3. That is not 2 times 3. This is 2 times 2 times 2. And 2 times 2 is 4, and 4 times 2 is 8. So we have to be really mindful when we work with exponents to remember that we are multiplying the base number, that's what the 2 is here, is the base number, the number of times that we have written in the exponent. So in this case, 2 is going to be multiplied times itself 3 times. Let's look at this example over here. Sometimes we have a decimal. Here's an example of 1 2/10 to the 4th power. So that means the base, 1.2, is being multiplied by itself 4 times. So 1.2 times 1.2 times 1.2 times 1.2. And then, of course, we get a decimal answer. All right, so I want you to make sure you get this next part in your notebook. If you aren't already doing so, please make sure you have that out, because I want you to notate this table of values. So what you're seeing here is you're seeing our 2 base to various exponents. So 2 to the 0 power is 1. And really, any number, or not really, but positively, absolutely, every number to the 0 power is 1. So n, which is going to represent any number, to the 0 power is 1. Well, 2 to the first power is 2. So that would tell us that any number to the first power is just that number. 2 to the second power, remember that is going to mean 2 times 2, 2 2's multiplied together, and 2 times 2 is 4. So that tells you that any number to the second power is that base number multiplied by itself. So there's a total of 2 base numbers. 2 to the third power would be 2 times 2 times 2. So again, the exponent of 3 tells us how many times we're multiplying the base. And we're multiplying, so it's 2 times 2 is 4, times 2 is 8. So that would tell us that any number is going to work the same way. Any number to the third power is going to be that number times that number times that number, or the base number multiplied by itself 3 times. Let's just do one more, 2 to the 4th. Of course, that's going to mean 2 times 2 times 2 times 2. It's really important that you remember that that's multiplication, because now we have 2 times 2, which is 4, times 2, which is 8, and 8 times 2 is 16. You should be noticing how quickly our numbers get bigger when we use exponents. So any number to the 4th power is just going to be that number, the number of the base, multiplied by itself 4 times. So n times n times n times n. Okay, also in this section, 3.1, you're going to look briefly at what we call scientific notation. And we've talked about this only briefly, and maybe you've had it a little bit in the past. But here's what you need to know about scientific notation. It's simply telling you how many times you're multiplying by 10. Remember, you guys, when we multiply by 10, we're just moving the decimal 1 time to the right. That's what multiplying by 10 does. If we divide by 10, just a reminder, we're moving the decimal 1 time to the left. So if we're multiplying by 10 5 times, then that's going to mean that we move that decimal 5 times to the right. 1, 2, 3, 4, 5. That's the placement of the new decimal. Since it lives at the end of the number, we don't need to write it, but we do need to write the number with now all of its zeros. So we have 1, 9, and we have 4 zeros. And then when we count from the left and put a comma in, we can read this number now as 190,000. Now, just real quickly, if we were to have not a positive 5 here, but a negative 5 here, that tells us we're going to move the decimal not to the right. We're not timesing by 10 5 times. We're dividing by 5 or by 10 5 times. And so remember when I said that when you divide by 10, you move to the left? So if we divide by 10 5 times, look what happens. 1, 2, 3, 4, 5. That becomes the new decimal. Again, we're going to put in our zeros, and we end up with this tiny little number. Look how small this number is. And so if we were to read this properly, we've got tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. So we would read this number as 19 millionths. All right. You're not going to do too much with scientific notation in this section, but that is just a brief encounter to this notation that lets us write really big numbers in a scientific, simpler form, or really small numbers also in an easier form. Okay, I hope that helps you guys. I look forward to the superset on 3.1, and I appreciate you listening. Thanks, everybody.